I'm just going to share my screen. Up next, I know we're going to be bringing Vinaya Manvatkar to the stage. So our next presenter, she is a lead engineer with the Centre of Additive Manufacturing at the research group of Eaton India Innovation Centre, and that's situated in Pune. Her work profile includes metal additive manufacturing processes and product development through experimentation and simulation. She likes exploring the impact of technical and non-technical factors, i.e. geography, economy, sustainability, etc., on the growth of manufacturing. Vinaya has completed her doctoral study from the Indian Institute of Technology, Bombay, and has completed postdoctoral fellowship at Pennsylvania State University in the field of numerical modelling of metal additive manufacturing and welding processes. She continues to work with academic institutes as an external examiner for bachelor's and master's theses and delivers guest lectures on industry trends in additive manufacturing. Vinaya has a total of 10 plus years of experience in the field of metal additive manufacturing and has published 13 papers in peer-reviewed journals and at conferences. And so today, I think we're running a little bit ahead of schedule, so I think Vinaya is ready. Vinaya, if you would like to bring up your camera, and I'll take down my screen in a few seconds' time. Vinaya is going to be presenting today on the topic of factors influencing adoption of additive manufacturing. And I'm just going to help bring Vinaya up to the stage. There we go. You should be able to find those buttons now. Wonderful.
Hey, hello, Karen. Thanks for a kind introduction. So let me share my screen.
Lovely. And where are you joining us today from, Vinaya?
I'm joining from Pune, India. Yeah.
Yeah, cool. Cool. All right. Okay, so I can see the presentation coming up. Yep, I can see that one there. I'm going to turn my mic and my camera off. Over to you, Vinaya.
Hey, thank you, Karen. And before I start presenting on the topic, I would, though I'm a presenter, so I would like to thank my colleague Ananda Pasala, with whom I have developed these contents, and he is from Eaton Center for Intellectual Property. I would like to acknowledge Eaton India Innovation Center and Mohan Trading for this opportunity, and colleagues from Center for Additive Manufacturing, Intellectual Property, and Sustainability to help me out to design the contents. So getting into the topic, so additive manufacturing, everybody is familiar with that, and it had started in 1980s, 85 with SLA, and new processes are coming up. It's evolving, DMLS, DED, binder jet, E-beam, and with the same things, there are multiple production level machines and technologies that are coming up. What is driving it is what it offers, right? It gives us mass customization, digital designs, which can be easily transferred, business model advantage for low volume, and even everybody has seen in the some disruption in the geopolitical or any other disruptions in the regular routine business. It has helped, but still there is always a question about its adoption. There is always it's up to not that comfort the way we have with our conventional processes. So we will talk about it in today's presentation. What are those factors which takes us out of that comfort zone? It is a very attractive process. It gives us freedom of design. So it allows us making more of functional, improved designs. Tooling requirement is reduced. Custom or specific solutions are made. It reduces use of high value resources, reduces interfaces, and it has other sustainability benefits as well. So if we have to see who are the users for this for overall these years, is it started heavily into the aerospace. We know many applications like holders, brackets, nozzles, impellers. It has percolated in other industries as well: automobile, electrical, medical, and consumer goods. But what limits its application is how the cost, annual volume, size of the component, performance expectation, and the related certification, if it is a very critical one like medical, flying component, for electrical, if it is a fire hazard, so UL certification. So that takes cost and time, and also the function and criticality. So applications are identified based on the specific benefit, and then it takes its own development route. So from the lens of user, one has to see, why am I taking the route of AM? Also think about AM feasibility, time involved in it, and all these three will affect the cost. So why am I turning towards AM? Are there any current manufacturing challenge? Are there any supply chain challenge currently we are facing? Because of disruption or because of overall volume has reduced, so the supply chain is not able to support it? Are we coming with a new product, or are you looking at the improvement in the current product through innovative designs? How my portfolio looks like? It is a single product portfolio or multiple product which I have to cater to, and what are the benefits I'm looking for? Benefits for as a user and benefits for the customer, both. So we can be user and a customer at the same time, and we also look for what we are offering to the customer. AM feasibility, so possibility of printing through geometry. What is the geometry, size, and shape look like, whether it is printable, and then are the materials available? So there are very specific materials which are currently qualified. There are still multiple materials which are needed for other industries. If you look at automobile, there are very specific materials are there and used in huge quantity in the terms of parts. So those materials are required. Are those available, or any alternative that we can look for? Which processes are suitable? If we go for metal, there are multiple processes. Polymer, there are multiple processes. So which process is suitable for us? Can it be made usable in as-built condition or through post-processing? So at least it should give us a window to post-process and make it usable. And after these efforts, does it satisfy my critical to quality points? Extent of process development required. It can be the AM process itself, or it can be post-process required, and at what cost it is coming up. So as I said, all the three components is going to reflect into the overall cost. AM has to compete with the conventional cost of current product if it is a current one. Also, if it is, it requires tooling, so it will be tooling plus normalized cost over the part. Then qualification and certification required, development cost, and investment in terms of AM systems and accessories around it. And this takes time, and time also will reflect eventually into cost. So the time for the development of it, product, process, standardization, inspection, and this is going to reflect into time to market. So both of the main components, which is cost and time, are the ones which gives us competitive advantage. And it depends on, are we using it for production or tooling or prototyping? So if we look at generally at the AM production cycle, so very critical components can take up to 3 to 4 years, 3 to 7 years till from AM development to the commercialization. Material qualification itself can be 1 to 3 years, and development cost can go from 100K to 800K. It involves all the development, product, process, material. So yeah. So this is normally the qualification stages look like: material qualification, then you go for process qualification and part qualification. And change of any of this has to repeat that particular stage, or maybe start, if it is a new material, it will start from the first stage itself. So if we want to see how the cost and time footprint look like, the majority of the cost is influenced by machine cost, material cost, and post-processing and inspection cost. Remaining portion is more on the consumables and overheads. So in the machine cost, it will affect in what kind of machine you are using, if it is a prototyping machine or the production machine. How is it utilization and the portfolio coverage? Because that is going to reflect into all your part. It is going to normalize onto it. And that can be a deciding factor, whether I want to house it or I want to use the ecosystem. Materials, if it is strategic material, then one has to optimize its use through innovative designs. Post-processing and inspection requires, if you want to reduce that footprint, optimization of print and also the post-processing stages, and come up with the innovative inspection technologies. For others, what is the strategy you use for printing? Can you print, we are printing in a batch, or we are decentralizing it, and how the time footprint, which will technically reflect into all other factors. Time, as I said, it involves print, development, qualification, supply chain, and inspection. And both the factors have effect of the region in which it is taking place. So the two important points to note is, we are making balance between speed, resolution, and quality. And it has significant impact of regional market on the material or system cost, labor, and overhead, because those rates are different in different markets. So based on that, one wants to centralize or decentralize the process. So if I have to house a AM technology, we have to think about, is my application is prototype, product, or tooling, or repair? Does my portfolio support my ROI targets? Which technology is most suited for my applications? Do I need one technology or multiple? There is a chance there is one technology I need which can support my majority of the applications, but there is still another portfolio, which is smaller one, which still need another technology where one can utilize a collaborator. And arrangement needs to be done, and planning needs to be done to support the volumes and meet timelines. So it is capital versus scale and capital versus scope that one needs to study. So the capital is the important factor, and if my portfolio is not supporting that, so can we utilize the ecosystem? Is the ecosystem for printing and associated pre and post processing is available? So if we use some collaborator or service, what happens is the overall machine and even material cost gets normalized over the multiple partners. So it can reduce overall cost. But when we use the ecosystem, the other points to control or look at is the traceability of process consistency, because definitely systems undergo upgrades, system undergoes maintenance, and there is an impact of how the machine is used, how long it has used, which is the version we are using, on the quality of the product. So the traceability of overall process and the consistency is very important. If we are working on the earlier stages, how the development and the technology transfer would take place between the collaborators. Hardware and software consistency as to make sure the quality in terms of repeatability and reusability. And how the management of any system or material related change. If we are working with collaborator, there is one system, and system manufacturer, OEM, has given some updates related to system and software, and how that can be accommodated. How is the translation from the older system to the newer system? Its quality is maintained. What are the factors which are controlled? So that asks for the requirement for certified facilities. Whether we house the facility or whether we use the ecosystem, we want to, or we look forward to reducing footprint of time and resource. And there is need to reduce printing time and overall processes. That can be done, developmental efforts can be reduced by supporting with the scientific approach, data-driven approach. In-process monitoring and control, where one can take the decision about the corrective remedy or whether to stop so that any eventual wastage can be controlled, time can be reduced, and immediate action can be taken. Overall process optimization from pre-printing, printing, and post-printing. We have to look into the overall process together to reduce value stream of that particular product development. New entity technologies are needed where we can reduce destructive testing, reduce qualification procedures, and integrated automated solutions are the one which are really needed, which would reduce the overall cost and increase the confidence on the process. So current AM restraints and enablers are challenges in manufacturing large individual parts, availability of qualified materials, certification, competing with cost with the traditional manufacturing, ensuring consistency in the quality, low degree of automation, and scaling and transferability of process from one technology. It can be one technology to another, also can be the same technology but a different mix. And so any work towards accuracy, quality, reliability, material reuse, high production rate, and increasing material range is going to increase the use and adoption of AM. So current developmental needs look like there can be hardware development in terms of systems, printers, which are faster, accessories, integrated accessories for the automation, and a more control over process for the post-processing system, in-process monitoring systems, and that can prescribe the solutions. Services related to printing, design platforms, training, and other solutions. Materials, definitely, as we discussed regarding new materials, new recipes, and bigger catalog to need to be opened up for application, and their respective treatments required. And software solutions, because all of this going to also help for the newer designs. So it can be design solutions for manufacturing who can take into account challenges related to additive manufacturing. Just to name is like support structure, where it is coming, how it would come, and what is its implication. Distortions, similarly. Process simulations and process monitoring, because that is going to reduce the developmental cycle. So these are some of the developmental needs. So a market is working towards it. So what is forecasted is current 13 billion revenue would ramp up to 44 billion in the period of from 21 to 28 with CAGR of 21%. And the distribution currently looks like it's 50% services, in hardware it is 27%, and the material development is around 23%. And it is general look around how currently revenue is spread across different businesses, where consumer product and automobile and aerospace are the ones which are leading. Based on the development needs, how the patent filing looks like is more, it has increased from 15 to the next few years. And top companies which are into the patent filings are OEMs, product owners, solution developers. And the potential market protection looks like it's from China, followed by USA, Europe, Japan, and Germany, South Korea. So as we said, how the development is looking like currently. So in machine and processes, the envelope is getting larger. There OEMs are coming with the monitoring and quality management system. So there are EOSG, CALSAS, certain acquisitions are happening for the collaborative work. New materials are being opened up. There are digital tiles which are getting arranged so that we can use a cloud platform, core technology releases. People are working on the post processing and its automation, and newer components are being opened up, and AM Avenue is increasing. Parallel to this development, definitely the standard are also getting developed specifically for additive manufacturing. When we see the adoption, there are other feathers to it. One is how the industry architect look like. So there is OEM, there can be MROs, and product and services transfer can happen from supplier to OEM to MROs and back and forth. And any of these can be a user of 3D printing. And that would help a stronger supply chain, reduce inventory and lead time, helping for the local manufacturing. This is being a digital footprint. Once the recipe is formalized, it helps easy transferability of process and can support just-in-time production. And when we are working on the supply chain and a supply chain, product innovations, efficient design, so that also one of the point to think what are the other sustainability benefits it can give us. The process and product design optimization can lead to the saving of resources, and a weight reduction as a part optimized for the weight reduction or performance improvement can reduce the fuel consumption. As we know, it is very critical for some of the industries. Consolidation of part can reduce the overall transport within the supply chain, and localization of also supply chain support the same. Also, the inventory reduction will reduce in overall, storage related sources, overheads, and controls. Those are required. So those are some of the aspects which can be supported, sustainability supported by adopting this. It definitely goes application to application. So it can be one or all the 3 points can be addressed. So with this presentation slide, I want to summarize what are the current trends based on how the adoption is, how the needs are, and how the markets are growing. So trends are looking for the improved productivity and flexibility in the existing technology, easy transfer of process, for scalability, also for the systems. New materials, increased end-use production, innovative designs, automation, hybrid manufacturing, reducing the post-processing and inspection times through monitoring and prognostic diagnostic solutions, lowering environmental footprint, and come with the more collaborative solutions where one can have one-stop solutions. So I want to end my presentation with this. I open the stage for any questions I have. Thank you.
Thanks, Vinaya. I found your presentation really insightful. It's a topic that's really close to, I guess, my heart as well. Looking at AM adoption here in Australia in the defence industry and broader, I guess, heavy metals industry. So thank you for sharing your insights. I found some of them align very closely with what we've got going on here too. So just a reminder, if you've got some questions for Vinaya, please put them into the Q&A and we'll start running through those. I've got one to hit the ground running, if that's okay. What I might get you to do is, if you want to stop sharing your screen, that will bring us back up to presenter kind of mode, and we'll allow people to see. Yep, fantastic. So in your opinion, and I guess this is a tough question, right? But what do you think is the strongest non-technical factor that's influencing AM adoption in the industry that's local to you? So in the country where you can see a lot of the industry, but then also more broadly at a global scale. What is this biggest non-technical factor in your mind that you feel is influencing AM adoption?
Okay. So I won't call it most influential, but I would say it is one of the things which come very predominantly. One is regional effect, when there are different initiatives make in particular region and you try to develop, right? That is one of the things. And every region is influenced by a particular economy. And that also drives the cost of any particular product, the type of regulations required at that particular region, and then it challenges the cost. So I think the economic developmental factors, region level, it's really one of the influential ones.
Wonderful. And I would say, what do you think are the biggest things impacting like logistics and supply chain into additive manufacturing? Obviously, there's a lot of things that need to fall into place to bring a final part together. What have you observed from your experiences as influencing logistics and supply chains quite strongly in the AM field?
So I think I would say how you look at the product actually. Is it a new design which is consolidated? It always starts with what you expect from the product, right? And then based on that you design it, and then it affects the thing. Are you reducing the parts? And any processes required for the part. So if you are reducing the part, you definitely reduce overall. If there are standard parts which are getting from the supplier, those will reduce, and that will reduce the footprint. But at the same time, if you are formulating a part which requires certain other procedures, you will send it again outside. Mm-hmm. So you might reduce one supply chain, you might increase another. So it is a balance between the two. And if you are dependent on the supply chain for the service, that is another factor, how we look at it. If we are housing it already with the conventional, because of any other reason you want to go with the AM and work with the supplier, it opens up a completely different, direction, mm-hmm. because you are housing it in and taking it now out to the supplier. So those are a few of the things, arrangements in terms of mostly how the business and product strategies are. Those drive those. Yeah.
Okay, cool.
But definitely one has to think because sustainability is one of the factors. But so we cannot isolate each and every factor. It has to be taken into consideration together.
That whole ecosystem approach, as you were sharing earlier. Yeah, cool. So Carol McDonald, thanks again for another good question. So here's one. She's got a double barrel question here for you. Do you think that the skill set of the employees impact the implementation of AM? And also, do manufacturers feel that they have to hire new employees when they want to adopt AM?
So for first question, I'll take one by one. Do you think the skill set of employees impact the implementation of AM? I would say yes. But skill sets can be developed. Process is new. We were new. But what I think is what is important to have the understanding of the process and its impact scientifically and also other impacts. So definitely skill set impacts. It needs more experience, hands-on, playing with the machine. It won't come in one day. And so skill set is required because the skill set also reduces your time. So whoever is hands-on on the system, who is more exposed to the system, how it functions, how it is to be designed, so it is going to reflect in the quality, how the person is setting up the machine, how the person is thinking about the product, because it is a back and forth between the performance and the manufacturability. About the second question, do manufacturers feel that they have hired new employees? It is up to manufacturer, because you can hire new with experience, or you can train the actual ones who have experience in manufacturing. It is still a manufacturing process. It has the similar basics like previously welling or coating, or it has similar needs related to heat treatment or post print machining, finishing treatments. So if you have someone with the basic understanding, you can train them and use the skill set. So a second is very dependent on the manufacturer though. But yes, skills can be acquired, and in fact there are multiple initiatives to develop this skill set all over the India and even globally. So
wonderful, thanks for that. I'm also finding, like, with additive manufacturing, it's tending towards more junior engineers. Like, as they're rolling through, it's a skill set that they're bringing into industry as they're exiting from the education systems as well now. So more and more people are aware of additive manufacturing and how it all works, and kind of have that ingrained with that manufacturing background. So we've got another question here from Katrina. What would be the role of the research community to help drive the adoption of additive manufacturing, in your opinion?
great question. So yeah, I think research is being done in a different directions. One is simulation, so development through analysis. Other things, making the largest systems. So if you are changing the envelope, the other accessories needs to be changed, and those kind of developments are needed. Those kind of research are needed. Research in terms of material, research in terms of technologies, because it started with SLA, and we are handling all sorts of material and all sorts of machines now. So those are the researches which gives a direction to think, to do the risk analysis. So when we try to adopt or look into the technology, those are the ones becomes a guidelines. So yeah.
Great. Well, thank you for that, Vinaya. Thanks for your insightful discussion today and sharing your insights and, I guess, exposure to looking at how all these factors are influencing AM adoption, I guess, at the local level and across the world, and even at an industry level. And thank you